Welcome class, and welcome to this new video still on quadratic forms. As a reminder, we said in the previous video that the quadratic forms of a two variable is given as equation 1 and its matrix equivalent form is given as equation 2. Now, remember that this is for two variables. Now, for three variables, we have ax squared plus by squared plus cz squared plus 2dxy plus 2eyz plus 2fzx plus gx plus hx plus hy plus iz plus g equals to 0, given equation 3. And the conic section that define the quadratic forms in three variables are known as our three surfaces, such as ellipsoid, cones, paraboloid, and so on. Now, as we explained previously, we know that if d equals to e and equals to f, therefore, the quadratic equation 3 can be reduced to a standard form by completing the square. But in the other case, if d different from e, if d equals to e or f or are different from 0, then we can rewrite equation 3 in its matrix form, which will be x transpose of a d f b e f e c x plus j h I x equals to minus t. This is equation 4. So again, please notice that this matrix is what? Is symmetric. Now, let's dive to this awesome example together. We are still in two variable quadratic form. Sketch the surface represented by 3x squared plus 18xy plus 27y squared plus 9 square root 10 x minus 3 square root 10 y equal to 60. Right? Sketch the surface represented by this quadratic equation. Now, how do you solve this? How do you approach this? As defined in the previous video, we know that, right? As a solution, the first step will be to write in matrix form. One can directly apply this formula from 1 to 2. So using formula 2 to write the matrix form. So from that formula, I'll have that x transpose times 3, 9, 9, 27. So because I have 3x squared here, so I have 3 here, and you have 18, since it is 2bxy in the formula, so I'll divide 18 by 2 to have 9 and 9, because the metric is symmetric, so it's b here, if you can remember. And then I will have that this x plus square root 10 of 9 minus 3, x equals to 60. I'll call this equation A, right? Now, what do I notice here? I notice that this matrix, I call it A, is a symmetric matrix. Therefore, if A is symmetric, therefore, the next step to do is to orthogonally diagonalize A. So, step 2, orthogonally diagonalize matrix A, right? Because A is symmetric. How do we do that? We need to find the eigenvalue and the corresponding eigenvectors of those eigenvalue. Now, the eigenvalues are given by solving the equation determinant of A minus lambda identity vector equals to 0. Now, we have intensively worked it out in the previous video, so no need to work that anymore. But here you have that this equation will give you this equals to 0. Then I will have lambda equals to 0 and lambda equals to 30. So I'll have two eigenvalues. And then for the eigenvalue lambda equals to 0, I have to solve this equation, right? put in v1, which gives me that v1 equals to minus 3, 1, right? And for lambda equals to 30, right, I have to solve also this equation. Give me v2 equals to 1, 3. Now, what do you realize? That here we can have the diagonal matrix, which is 0, 0, 0, 30. And then we can also have the P matrix, which is the matrix of the eigenvector. Now, we need to find the orthogonal matrix Q, right? And to have that, we have to scale each vector so that it has a norm of 1. So we have Q then will be equal to, because the norm of either V1 or V2, as you can see, is equals to square root 3 square plus 1 square, which is square root 10, right? So this will give me that 1 over square root 10, right, of minus 3, 1, 1, 3. Okay, so having this, let's go to the third step. The third step will be to introduce new axis by letting that x equals to qx. And then it means that x transpose will equals to qx transpose, which is q transpose x, which is the same as x transpose q transpose. And the x is x, y. Then substituting this into the equation A, which is written as, I'm rewriting equation A over here for simplicity and understanding, right, equal to 60. So this is equation A that we wrote before. Then if we replace this, all of this, right, into this equation, we have that it is given by x transpose q transpose aq, right, x plus square root 10 9 minus 3 qx equal to 60. So I realize that this is the diagonal matrix D. So I have x transpose x, right, plus square root 10 9 minus 3, right, times q minus 3 1 1 3 x y divided by square root 10 because of the q equals to 60. Now then I will have that x y times 0 0 0 30, which is D, times x y, right, plus if we do the multiplication of this and this 3, if we do the multiplication of this 3, we will have that this will give minus 30x, right, equals to 60. And if I do the multiplication of this, right, it will give me 30y squared minus 30x equals to 60, right? Simplifying everything by 30, I have that this equals to 2. So it means that my equation is y squared equals to, or y squared minus x equals to 2. So this is what? This is a parabola. Now the fourth step therefore would be to plot, right? So I'll start by plotting on the new axis. So I have y here and I have x here. So I have minus 2 here, because if y is 0, x will be minus 2, and if x is 0, y will be square root 2 and minus square root 2. So this is how my parabola will look like. Okay, now what are the new direction? What are the new direction? Remember that we said that x equals to q x. So if I want the new direction x, it will give me q over, right, q, and I take the elementary vector 1 0, right, and then the other one will be q as well, 0 1, right? So in all of this that that you have, so it will give you something like this: minus 3 1, and then you will have 1 3. Now if I want to plot this now on the new on the new axis, then I will have that my plot will give something like this, right? Then if I have here my y, and if I have here x, so I will see that the new, if we somehow, if I somehow like this, like 1, 3, and then I have minus 3, 1. So I'll have then that my new axis will come this way. This will be y, and this will be positive x. And then with that, I then have this is minus 2, and somewhere here will be square root 2 and minus square root 2. So it will be something like this if I do the red. Okay, so this is also my new curve. So in this video, you saw how to find, or we saw together how to sketch, right, a surface represented by a quadratic equation. We saw the first step, where the first was to first write in the matrix form and to identify the matrix and orthogonally diagonalize the matrix, define the new axis, and plot the sketch. Thank you.